So welcome to Tor's Structured Cyberspace. The format for this panel will be about 25 minutes for each speaker, so 15 for the presentation, then we'll have a bit of questions, and we'll open up to the audience. So we'll focus on each individual presentation for a short bit of time. Our first speaker is Kim Hartman, who will be presenting net neutrality in the context of cyber warfare. Kim is a senior IT security consultant and a researcher at Cyber and Information Security Development at the Conflict Studies Research Center at Cambridge, UK. She specializes in mathematical modeling and security analysis of networks. So we look forward to her presentation.
Okay, so thank you for the introduction, Brandon. As you already said, I'm going to be talking about net neutrality in the context of cyber warfare. I'm going to start out with something that I normally don't do, and that is actually, because I know this has been a very emotionally driven discussion, to actually start off with saying why we wrote this paper and why we didn't. So first of all, what we don't want to have is ISPs charging you for your common day, everyday usage of the internet. Of course, I'm also just an internet user as everybody else is, so I don't want to be extra charged for that. Just to kind of take that fear away, because that's the first thing that jumps into people's minds when you talk about net neutrality. What we want to do is actually to raise the awareness of what net neutrality really means in technical terms, how it is implemented nowadays, if it isn't implemented, and what this actually has to do with cybersecurity. So what we're going to look at from the first place is cyberspace today. So today we are confronted with a wide range of devices, protocols, and use cases with very exchangeable mobile devices. So given this scenario, you can imagine, and you will know, that it might very easily have devices ending up in networks that they are not designated to. So from a computer security point of view, that actually means that each device that is somehow connected to networks imposes a potential threat to the network, because through each of these devices, all of them they may be running their own operating system, having their own configurations, having their own services that they're actually working with, and all of these, even the protocol implementations may vary depending on the hardware that you're using. So all of these aspects actually may depend on how good they have been implemented, and there was impose a threat to the network that they are being connected to. And by that actually connect to cyberspace again. So you might actually end up not having your network connected to cyberspace directly in terms of the internet, but actually through some device that shouldn't be in that network. And for some reason, your network configuration failed to block that. So having said that, this is actually what is making cyberspace such a highly contested and congested domain, and which is why we are so interested in it as cybersecurity specialists. But the question that may still be in the room is, why should we, as a cybersecurity community, actually be interested in net neutrality? And what most people think about when they hear net neutrality is actually discussions on the freedom of the internet, or whether ISPs may charge for equal services differently. So you have zero rating coming up, or has been up for quite some while, but by now. And you have the limiting of speeds for specific services or specific connections, depending on the load balancing. So those are kind of the things that come to your mind quickly. However, it is very important, and this is one of the main points that we want to stress, that net neutrality is a regulatory principle that is designed to regulate traffic management in networks, and specifically, of course, on ISP sites. It is not a structural condition, and nor is it a technical implementation. So this is something that many people actually believe when they hear about talking about net neutrality, that they actually think that this is something that either is demanded structurally or that is actually technically being enforced. And that's the big point. It's not. It's a principle. It's more than an advice, but it's not being enforced in that terms. So, and this is one of the findings that we had in our article, is actually that there are very different interpretations and implementations, even just within the EU. You will find countries that have a very strong sense of net neutrality, that have very strong limitations, and there are others that allow zero rating and everything that you can think of. So what we're also concerned with is to transfer is actually that ISPs provide what we would call the physical backbone of the internet, and many civilian and there with many civilian corporate and even some governmental services. So if something happens to this physical backbone, then you're going to be in big trouble. And that's why you should be concerned with any regulations that you're putting on them. So, and that's actually something that we must be more aware of, because our opponents are. They are aware that our ISPs are crucial assets for anyone who is seeking to control cyberspace. ISPs may actually also play a major role in cyber incident assistance by remote allies during joint operations of distributed cyber units and when assisting civilian infrastructures that are being attacked. So that's actually where you come into the whole cyber warfare aspects of this talk. So looking a bit more on what actually are the effects that net neutrality has on networks. So net neutrality, basically, I presume that everybody knows in basic terms what net neutrality is, which basically states that you're not allowed to tamper with data in a way, or with data traffic in a way that is preferring one over the other if they are equal data packets that you're looking at. So it is, net neutrality has effects on how the available bandwidth is distributed and whether specific sources or content may be monitored, how intensely it is allowed to be monitored, and to what extent actually observed activities can be attributed. I'm going to go more into detail about that in a second when I'm going to show you one of the examples. And actually, what we also found out is that ISPs have actually complained that even if they are able to recognize that a potential source of an attack isn't the attacker itself, but rather a bot that is being abused, they are not able to go beyond that, not due to technical limitations, but due to regulatory regulations. So they can't go beyond that just because someone said you're not allowed to. And this is where we have to rethink our understanding of net neutrality, because right now net neutrality protects both the ordinary users as well as malicious actors. So what I'm going to show you with the following examples is how net neutrality may actually be abused to control traffic by hiding the true source of activities, by abusing the equal treatment of data packets, and by circumventing net neutrality. So the first example that I picked is a rather straightforward one, because I assume that everybody will know how a DDoS attack is actually carried out at least from basic points of view. So we're going to look at it from a net neutrality point of view. So from this perspective, there are two things that you have to consider, because there are actually two different aspects how DDoS uses net neutrality in two different locations. So on one side, you have on the victim's hardware by occupying the system with the processing of data packets being resent all over again. That's actually when you have your botnet sending all the packets to the source or the destination, and the destination has actually been taken up by just having to process all those packages. Now, what you have to bear in mind at this stage is you might just say, oh, well, you could just drop them. But the thing is, from a technical point of view, even dropping a packet still means that you need to do the processing. You still have to take this packet, you have to receive it, you have to go have it through your OZ stack, and you have to look at it, what type of packet is this, and can I drop it or not? You can't, there's not a wall in front of this where you just kind of have the packets jump off. So that's one point where you actually have DDoS working, and the other location where that DDoS abuses is on the network, by implicitly abusing the fact that equal requests must be transmitted equally. So actually, by sending all of these packets, on one side, you have on the victim's hardware, the hardware being occupied by processing the packets, and at the same time, also on the network, you are actually taking up the bandwidth. And you're abusing the fact that all of these packets must be treated equally. So, and by that, you're actually occupying more bandwidth than you should. That's one of the other ways how DDoS abuses net neutrality implicitly. Now, DDoS also uses the fact, which I also already mentioned on the previous slide, that it is difficult to trace back the data flow to the original source. Now, this is a view that an ISP could easily get if they were allowed to go beyond what you can see directly from what you find at the target being attacked. So if you were allowed to cooperate and to actually do some more proactive steps previous to an attack, then you would actually be able to directly see, okay, this is actually a botnet doing a DDoS, and this is actually something that I can identify directly, and I can even identify the attacker in one instance. So this is another aspect that you should bear in mind when talking about net neutrality in the context of cybersecurity. So moving on to the second example, which is a more recent one. I'm sure most of you will have heard about this coming up the last couple of days, which is the VPN filter. I'm not going to go too much into the technical details of how it actually works. It is very interesting, at least I think so. What you would like to know probably are the dates, which is that there are at least 500,000 devices being infected in at least 54 countries. And Ukraine being one of the countries, or being the country mainly affected, second place followed by Germany. The devices that are actually being affected are networking equipment in the SOHO space, so it's small organizations and home offices that you're looking at mainly. So with network equipment, I mainly mean routers, and the QNAP network storage systems. At least these are the ones that have been known so far. As I said, the investigation is still going on. And what you know from VPN Filter is that it is a three-stage malware. So it is actually, there are 3 stages to it, where the first one is mainly just the infection. From what I know, they are not absolutely sure what exploits they have been using to actually get VPN Filter on the routers. But they know that there are some concerns with that they are using initial credentials. So by changing your administration password, you should have been able to circumvent or prevent some of these problems. But knowing that, it's very dramatic to see that there are still more than 500,000 devices being infected, actually. What we also know is that they are building an SSL communication link and that they are open up to Tor. It's not one, it's actually several communication links that are building up. And it's also, by now, it's known to be sniffing and to be modularized, so you don't really know the full potential of it yet, because you don't know what modules there are that could be got from the VPN filter, from the malware. However, with what we know so far, one could actually imagine. Now, what this picture is actually trying to tell you is that you have the red ones are the infected ones. So you have red are infected routers, it's an infected server, and the red lines are the infected connections. So what you can actually see from this picture, and what you can imagine when you look into the technical details of this, is that you're actually able to build a private network through these. And that is actually a way of circumventing net neutrality in those terms, that you are able to install a privileged access to these routers, which you normally wouldn't have. And by that, depending on the network that you have actually gotten into through the router, you may actually be able to move rather far into that network. And another point that many people are very concerned with VPN filter is that it's actually known to have a kill switch. Which is making the device dysfunctional. And therewith, of course, this is again depending on what network you're actually on, it may take down the whole network that is associated with that device. So, of course, as I said, this is a piece of malware that has been directed towards SOHO space, so small organization and home offices. But if you would find a similar malware that is actually being directed to more sophisticated network devices, which this is actually proving that it is basically possible to do this, then, of course, you can imagine what this would mean if it would infect a bigger corporate network, or even a governmental network, or if it at some point may even end up in clouds, or cloud server farms, or at ISPs. So this is one of the other reasons why I picked this example. So I'm unfortunately running out of time, But there is a quick summary of what I've been said. There's more in the paper, so if you want to have the specific details, you will have to look at the paper. But what you really should be getting from this talk is, first of all, net neutrality is a principle that is affecting network traffic. So it's a principle, it's not a technical implementation. There are implementations of this around, but they are very different depending on what country you're in, what ISPs you're looking at, and so on. And the other point that you have to consider is that network traffic control is a part of cyber activities. Somehow it's almost always related to cyber activities going on. And the other thing that we need to bear in mind is that legitimate actors are bound to these regulations that we have imposed on them, while the malicious actors aren't. So in this term, we are actually making an imbalance in cyberspace by the regulations that we are provoking. But what we, of course, also want to stress is that net neutrality regulations, if we are rethinking them, still have to bear in mind the protection of individual rights and the equality among civilian end users, but they must also ensure the stability of cyberspace and allow legitimate actors to rebalance cyber power and regain control over congested networks. So I hope that I've made my point clear, and if there are any questions, I'd be happy to take them. Thank you.
Sure, thank you. I think one of the key questions I have is, you note the idea that net neutrality allows powers to rebalance cyber power. So can you unpack that a bit? How does that work? How is this rebalancing happening through the principle of net neutrality?
So what you're kind of asking is how, if you were, well, the problem right now is that net neutrality isn't, so it is actually doing the imbalancing. So you're not balancing the cyber power through it. You're actually doing the imbalancing by actually preferring the malicious actor because he is not bound to net neutrality regulations, because he has the technical means to avoid them or to just ignore them, while the legitimate actor will also have the technical capabilities of doing this, but he will not be able to do it because he is bound to these regulations. So that's kind of that answers your question.
Does the panel have any questions?
I'm curious from your perspective how the relationship between these different regulatory agencies that are exploring net neutrality, the different groups that are talking about it, how that discussion has been influenced by security to the extent that you've seen it. This is a sort of a novel argument to my experience, but I'm curious if others have taken that up.
Well, to be honest, from the feeling that I got from what I've been looking at in the EU and UK and Kiergals has been looking at in Russia, I feel that at least within the EU, it's not a very big issue. In UK, it is to some extent. This is also the reason probably why UK has been listed as one of the enemies of the internet by the Reporters Without Borders. And of course, Russia seems to be very aware of how net neutrality is actually imbalancing cyber power, and they are actually addressing it quite well, as we probably will be hearing later on from Pekka. So,
Thank you. I think we have time for 2 questions from the audience, so let's make them good.
now you scared them.
Why can't ISPs mandate through their consumer agreements with their clients to manage the security at the level there? So they have you presumably create when you have an agreement for a provision of a service, if you're in violation of that provision, you have to update or manage that. And so instead of privileging packets or doing other types of things, why not take other methods in normal service level agreements and other types of activities to manage the malicious actor problem? Why attack net neutrality instead of attacking it at the source?
I'm not explicitly attacking net neutrality in those terms. I'm actually pointing you towards the fact that there are actors out there who are attacking net neutrality and who are abusing it for their own good. So that's the point that I'm trying to make. Actually, within the EU regulations that just came up, or that is about to come up, has been lots of discussion going on since 2016 on this. They're actually defining specialized services within their perspective of what net neutrality is, where they are saying, well, we are thinking of specialized services where there might be exceptions for net neutrality. So they're actually, by taking your terms, attacking it themselves. But I'm not sure whether I'm answering your question, by the way, at this moment. But the thing about this is that they're more thinking about whether you should be able to have, I don't know, Netflix, for example, that should have, if you're somehow, as a corporation, if you're somehow associated with Netflix, that then you should be able to kind of be able to not rate your users for using that. So that's more kind of going into the zero rating direction. But actually, that's one of the criticisms about these specialized services, that nobody really knows what they explicitly are, because the regulation is a bit blurred on that point.
Great, thank you. I think we'll move to Troy Herr's presentation. So Troy Herr is a senior security strategist at Microsoft working on cloud computing and policy with the Global Security Strategy and Diplomacy team. Prior to Microsoft, Trey held a fellowship with the Belfort Cybersecurity Project, the Harvard Kennedy School, and he also received his PhD from George Washington University.
All right. Well, thank you, Brandon. Thank you, everybody, for coming out for a post-lunch panel. What I want to talk to you guys about today up here, hyperscaling, the structure of the internet in the second age of cloud. What does this mean? The argument I'm going to put forth is that cloud computing has evolved to a point where we've begun to see a concentration of computing, network, and storage resources and in governance activities within a fairly small set of cloud service providers. And that the implication for that concentration, for the growth of those providers, and for the dominance, the growing dominance of cloud computing as a standard business line of practice piece of technology, is that the structure of the internet has begun to shift. And that this is not the first shift, but it is an important one. So first, quickly, what is cloud? The conventional explanation for what cloud is breaks it into three service models, three ways for you to consume cloud. Infrastructure as a service, raw compute resources, virtual machines, network bandwidth, storage space. Platform as a service, abstracted up a layer, services like machine translation, IoT event management, analytics, things you consume not as individual compute resources, but as an abstracted service delivered to you. Or software as a service, the sort of highest tier, what we think of facing the consumer. No awareness, no management for the actual computing engine underneath what's being delivered, merely a service that you can use at a web portal, something like a browser, something like a piece of productivity software like Excel. These are the three sort of conventional models for what we talk about when we think about what is cloud. But cloud is actually much more than just what you do in terms of how you consume it. Cloud is giant racks of metal. It's huge networking gear. It's piles of concrete stored in acre-long size buildings. Cloud is fundamentally management of millions of compute nodes and a tremendous compute infrastructure. So when we talk about what the cloud is, what we're really talking about is attempting to build, maintain, and update over time an incredibly large and diverse set of computing pieces. Some are devoted to customer-facing services. Some are devoted to pure management problems. Some are themselves the resources being sold and administered. The cloud in this instance is rack-based servers that are combined to create those three service models we talked about a second ago, IaaS, PaaS, and SaaS. Taken a scale out, the cloud are these acres-long buildings of concrete, massive cooling infrastructure and power. The cloud is a substantial utility function. It is a major infrastructure problem. It is not simply something delivered to a computer. It's not just a new form of computing. It's a new form of architecting computing services. So how do the cloud and the internet interact? Distributed computing has been around for decades. What makes cloud computing interesting is the internet allows service providers to deliver these services directly to individuals. Right? So rather than having to have direct physical access to a network or to compute resources, you can log into a terminal anywhere in the world and be able to access infrastructure, platform, or services delivered directly to your machine. The internet also drives demand in the way the cloud is structured. One of the things we're going to talk about a little bit later in the presentation is how the e-commerce revolution actually drove the creation of much of the infrastructure now being sold as cloud today. So the internet is both a delivery vehicle for cloud computing, but also a demand signal that's driving the creation of much of this infrastructure and technology. And then taken together, these two signals drive iteration and services. So this relationship between cloud computing and the internet is fairly fundamental. It's at the origins of what we think of as cloud computing. It's what drives much of the innovation in these services, and it's the paradigm by which these services are consumed. But let's take a step back from that. One of the arguments about cloud is that it's a return to the kind of concentration of computing that we saw with mainframes, where small groups of individuals maintained large computing devices to which individuals could gain access to on a sort of time-based, time-shared basis. So this is the 1950s up through the 1970s, dominated by IBM, large, big iron systems that were accessed in sort of small time windows. These were resources that were parceled out to individuals. It's the emergence of these early, what were not at the time called local area networks, but were essentially small access networks to these computings and these machines. Through the 1950s and 60s, we see mainframes evolve. In 1969, we have the creation of ARPANET, the precursor to the internet. The first time there is a distributed, national, in this case, internetwork of individuals, institutions, and computing facilities all communicating back and forth, right? The beginnings of what we know today as the internet at scale. ARPANET in 1969 doesn't have a tremendous impact in the near term on mainframe computing systems. It's not until the emergence of the microcomputer, what would later become the PC, that the internet became this all-powerful phenomenon connecting individuals across the world in their homes. This brings us into the World Wide Web. First in 1985 with the first Intra-Op conference, right, where we adopted common standards for how we were going to move packets around the web. Later in 1989, when Tim Berners-Lee first comes out with a proposal for what would become hypertext, this ability to take text and link pages across the web. The markup language and the basic lingua franca for how we would communicate between websites in the years to come. Microcomputers and the World Wide Web were the first instantiation of what the internet could be. It was not yet any examples of cloud computing, but it was areas where you could see distributed computing and connectivity taken together. That would change in 1995 with the beginning of the e-commerce revolution. Suddenly, the World Wide Web gave way to this massive rise of platforms for search, for retail transaction, for the kind of optimization and content delivery that we see as a basic part of the web today, as built into the fabric. The change with the e-commerce revolution is it drove companies to create massive compute and networking infrastructure to both deliver services to individual customers, but also to drive optimization of those services, ad delivery, content personalization, the sort of large server farms that you see in sort of media and stories built to deliver resources to individuals. This is what the e-commerce revolution drives. This is not the beginning of cloud computing, but it's the beginning of scale computing within these companies. So from 1995, with the emergence of eBay and Amazon, up through about 2006, we see this spike in the creation of large compute infrastructure, these massive data centers. Then in 2006, it occurs to someone that they can actually start selling access to these resources, some of this spare capacity. So Amazon launches Amazon Web Services, the first cloud computing company, and the race is on. IBM, Oracle, Microsoft, Google all follow in offering access to their data centers and this carefully constructed infrastructure that they've built over time to sustain these large web properties like search, like retail, giving them direct access to consumers. Over the years between 2006 and 2016, this went from being selling spare capacity to becoming its own driving business. Cloud computing came into its own. That's where we start to see the emergence of these three service models, IaaS, PaaS, and SaaS. Now, there's a really important distinction that we see with cloud computing over what we'd seen before. The internet, in its original instantiation, is premised on a client-server model. I have my machine, I'm calling out to your machine, we establish a link over the web. That point-to-point connection is the basis for an internet link, what we think of as an internet connection. Cloud computing is based on multi-tenancy, is an idea of multiple users being able to exist on the same computer through a technique called virtualization. Rather than having to have one user on a single piece of hardware, I can abstract that hardware through something called a hypervisor and place multiple users on the same computing device. I can most efficiently use that computer, right? So I can now most efficiently sell these resources to individuals around the world. Multi-tenancy drives a kind of intercomputer communication within these data centers that didn't exist within the client-server model. So this is a really important concept. In the client-server space in the 1980s and the 1990s, you had typically what was called north-south communication. I, as a user, was accessing a resource in a data center. My data came into the data center, hit the server, did some computing, did some storage and processing, and then came back out. The primary networking path was between the user and the server, the client and the server. In cloud computing, what we started to see was because all of these resources had been taken and fragmented, built out into these massive scale data centers, you actually saw communication between each of these resources before they went back to the customer. what was called east-west networking. So this drove massive changes in the way these data centers and this infrastructure had to be constructed. So between 1995 and 2006, you saw all of these major cloud companies taking what were legacy systems and equipment dedicated to this client-server model and supporting these large web enterprises and rebuilding them and re-networking and wiring them together in order to sell cloud computing and build it into what we know today. 2006 to 2016 is the real heyday for cloud. But what comes next? What is this piece that's really going to impact the next structure of the internet? My argument is something called hyperscale cloud. This is not my term by any stretch of the imagination. But what distinguishes hyperscale cloud from cloud computing? The first is sheer size. There are a small number of clouds, public clouds in the world today that have more than 1 million compute nodes. There's a small number of companies that can manage that size, can keep those nodes healthy, can keep them updated, can run security, can manage attacks and events within them. The size of that infrastructure is a really important denominator for what makes hyperscale. The second piece, though, is the reliance on this east-west connection. Am I selling cloud in this sort of traditional IaaS model where you get to log into a resource and use it as your own and then fly back out? Or am I selling more of these PaaS and SaaS services where I've got resources talking to each other and services building on top of each other? That defines the hyperscale cloud, this size and this different content delivery model. Now, before we talk about security, we should get a sense of what kind of scale we're thinking about here. This is an example slide looking at a major cloud vendor. You might have an idea who. In terms of the total scale of their network backbone, the size of their data center and region build-out, and the total scale of compute nodes that exist within those data centers. This is a planetary scale compute engine. And there's a couple companies that can offer this kind of resource, that can wire it together in this way. What does this mean for the internet? Looking at 2 million kilometers of intra-data center fiber, you have millions of kilometers of fiber. You have billions of dollars of investment that are going into connections between resources that do not cross into the public internet. These hyperscale clouds constitute independent compute environments, talking out to the internet, talking out to individuals and users and organizations. But much of that content, much of that networking flow existing within these clouds, within these large networks. How does that impact the structure of the internet? How does that impact the way we think about security challenges when there are these large entities that exist in this bubble? So we have to think about going back to what is that internet? David Clark, when he's talking about how he's thinking about the web, when he's thinking about the internet at that time, says he's recognizing point-to-point connections, where he wants intelligence to live at the edge of the network, to see absolutely dumb agnostic devices passing connections between users. That's the original model. Now you have this tremendous intermediary intelligence, where you are taking a packet, moving it to a server to contact the cloud, and then that data and that process is going all over the place within this cloud and then coming back to you or going to another user. Suddenly it's not a simple point-to-point connection anymore. There's also a change in trust. In the 1990s and the 2000s, we have this idea of a massive constellation of untrusted nodes all over the internet, individuals talking back and forth to each other in untrusted space. Here, when you reach out to a cloud, you have a single provider responsible for governing and securing that infrastructure. Suddenly you're not talking out to a random untrusted user anymore. The security environment, the potential risk is absolutely still there. But the partner and the interaction that you have with that partner are massively different. So what are the implications for security? There are several advantages and some disadvantages. I think it's not a lie to say that cloud is by no means a panacea, but there are some very interesting opportunities when you start to concentrate the scale of computing resources into single entities who can govern and operate in a consistent way. The first is with software attestation and patch management. There are opportunities for cloud providers to recognize untrusted code across customers in a way that's not present when you're operating a single enterprise. You can detect deviations in behavior. You can detect untrusted entities and applications because you may see 1,000 of the same company, and you have a good sense of what their profile should be in terms of software that you're using. You also have the opportunity to build management tools to patch and update systems across millions of nodes as opposed to company by company. Right? That's a powerful tool that drives defenders to react much more quickly, right? And maybe even gain pace on the attacker. Second is you have this idea of rapid response and iteration. You can bring to bear tremendous incident response resources across the company, across an entity, when you have a large cloud provider, because you can justify the economy of scale associated with hiring tens, hundreds, thousands of security professionals and keeping them on the permanent payroll. That rapid iteration piece is not to be underlined. The ability to re-architect a system in the event of an attack or a known vulnerability, to rewire a set of connections within an organization on the fly, these are the sorts of management and dynamic infrastructure tools you have within hyperscale cloud computing that are difficult to envision. A good example, if I want to rewire an enterprise network, I have to go and literally change plugs into different routers in different places in a building. Talking about within a hyperscale cloud environment, I can input a set of new tables to my software-defined routing infrastructure and overnight have rewired that network in the same way without having to run and change cabling anywhere. That kind of push-button change provides a tremendous defensive advantage to change the landscape that the attacker and defender are operating on. Third is this coordinated incident response. Again, leveraging those tremendous resources to be able to attack at the point of an incident and learn over tens of thousands of events. Now, two potential challenges here. Because again, security in the cloud is not a panacea. First is this idea of intra-cloud attacks. Attacker and defender existing in the exact same trusted network, the exact same infrastructure. This is a reality. This happens today. And the sorts of policy and security scenarios that we spin out in these environments don't usually take this into account. So this is a novel challenge. The second is this understanding the seams between customer and vendor. When your infrastructure has been built into this trusted cloud and has been wired together of all these different services, it now becomes very difficult to understand the security boundary between you and the vendor. It's possible, but you have to be much more disciplined. So closing, we have this idea of what the cloud offers us. Fundamentally, hyperscale clouds offer the potential for massive intelligence, event data collection and security response, the same basic principles and activities that we see today in the enterprise environment, taken across a scale that is managed in an automated and incredibly active fashion. This hyperscale kind of environment offers security opportunities that may not exist where networks are comparably smaller or managed at a human scale pace. Finally, it gives us an opportunity to leverage all of the resources, all of the concentrated talent of a large organization. Think about information sharing across 100 different banks. Take all those banks and put them on one network. Right? Solve that problem of being able to talk back and forth between those entities. That's a tremendously powerful tool from a security standpoint. So a quick conclusion, and I'm run out of time here. Last year's CyCon 9 theme was defend the core. The point that I would put forward to you, or the challenge I would put forward to you, is think about how do we define what the core is that we're defending. The hyperscale cloud and its impact on the structure of the internet has shifted this idea of what the core might be. Is it addressing and routing protocol infrastructure? Is it access infrastructure to cloud service providers? Is it actually these clouds, or the basic technology, or the basic components that exist in them? Right? That conversation is a really interesting one. It's going to drive the sort of security dynamic we see in the next couple of years. Awesome. Sorry, I blown out, but thank you very much.
Thank you. So the way you articulate the Cloud 2.0, it seems like we're bringing the levels of analysis problems back in. And now, where does the state reside in this structure? And what if the state chooses to strike back? Then what?
Strike back how?
To reassert control.
So I think the state is always there. The state is everywhere. I don't think that the argument about how hyperscale changes the structure of the internet is an argument that the state has relinquished control in any way. In fact, I think when you look at the language that gets used by these large cloud service providers and the kinds of engagements that they drive with government policymakers, the regulatory environment is top of mind. And it's a key driver for how systems are architected, what things are possible and what are not. GDPR is a great example of this. Right? The amount of time, effort, and energy that's gone into making sure that those regulations are not only drive for compliance, but also for behavior. Right? It's an absolutely massive investment, but it's one that you've seen a lot of companies take on. So I don't think the state's advocating authority simply because of this change in the structure of the net itself. Yeah?
Can you wait for a microphone, please?
Thank you. Sorry to interrupt the whole questioning stream, but I'd contest that because you're global, so you're multi-state. So where is your allegiance, right? Yes, you say your regulatory compliancy is being enforced through US government, US company. Very different to, obviously, the Chinese regulations, very different to Asia-Pac regulations, etc. You're not enforcing those same regulations. I know that Microsoft Cloud advocates regulatory compliance and has the best in the industry, but you're still not compliant. It's Western driven.
So I think it's a mistake to assume that because there's contesting regulatory models that there's not areas of overlap. One of the interesting challenges absolutely in the space is that you do have states with, I would say, fully formed opinions about how they want to regulate technology companies, how they want to regulate service industries. In areas those clash, in areas those overlap. The idea that there is a broad choice that would only endorse one of those models, I think, is not necessarily inaccurate. It's mistaken because there's not that same degree of clashing. I think there's a lot more areas of overlap than we would think. And where there are areas that conflict, absolutely, there's friction that emerges there. Companies make different choices, and you see that all the time. Some of that's about access to different markets. Some of that's about the choice to engage with a regulation that's seen to be wrong or illegal or malicious. I think that's a broader debate than simply endorsing a Western or a different model.
Well, thank you. I've always wanted to ask the question, how dare you? Any other questions from the panel? Okay, we'll go to the audience then.
Sir.
Yeah, just two kind of observations, actually. In terms of the red side of your picture of the risks, you carefully didn't talk about the monopoly lock-in risk. And I think most public organizations should be very, very concerned about that, because certainly you have a very price competitive, essentially, the price per computing support at each one of those layers is far beyond what anybody can afford to replicate on an on-premise solution. That's absolutely clear. On the other hand, once you get locked into a particular architecture like Azure, your ability to shift to another one is so hugely expensive that suddenly your negotiating power overwhelms what any organizational negotiating power is. And I'm not sure anybody's really considered that from a regulatory standpoint. I see that as a big risk. The second thing is, I think Kim actually offered a very subversive alternative to the cloud architecture, which is the hyper parallelization and microprocessing through agents that are placed, even down to the small mobile device level. I mean, right now, we don't know how many processes we may be running on somebody else's behalf on our phones as it is, which is in effect a parallel dark cloud, which in some ways has the value of giving us some survivability if we get into this lock-in situation with you. So I'm interested to see how this evolves in the next few years, because it is absolutely true. Your hyperscale has given you an edge, but I really wonder how long that's going to be sustainable, given the fact that through smart software parallelization, I can distribute this to any device that I can get access to, whether it's willing or not willing to share my processing load.
No, so I think it's a really interesting point, just to respond quickly. The vendor lock-in issue is not a new one, right? I mean, people have talked about this since time immemorial. I am using SQL software, so I'm locked into that as a database model. I'm using a particular version of an operating system, locked into that as a compute model. So that's a good and long-running and valid concern to bring up. Where I would push back is the surprising degree of open source standards and software that end up getting leveraged in a lot of these cloud service providers' infrastructure. So using, just as an example, if you want to rent a large number of virtual machines and run Red Hat, you can do it at any of them. And the ability to move data between those two is pretty fluid. It may be a pain in the butt, but it's absolutely something that's possible. I think there's, in some ways, far less vendor lock-in that you see today than you would have with, say, the IBM 700, 7000 series systems back in the day, right? Where Big Iron and Big Blue is going to come and sell you not just the system, the equipment, the model, the software, but also all the supporting infrastructure for it, which is not to knock IBM. I mean, that was a successful business model in the day. But I think there's such incredibly cutthroat competition here that the standard that's being demanded of the industry is this, not just interoperability, but intermobility. And so you're seeing a lot of entities come out and I think start to recommend this multi-vendor model as a way to endorse cloud. And I think a lot of people have done that successfully. As for the dark cloud, we'll see. I don't know that, I would be curious to see if the scale of coprocessors and ARM devices and the chips and the Qualcomm chips that you're seeing in phones are going to get close to matching the scale of some of the equipment being built out within these hyperscale providers, and the control and management challenge of computing in parallel over a cellular connection is an interesting problem, but it's a cool idea for sure.
I believe Kim had a question or a comment?
One quick one. If you just kind of think of the difficulties that we've been experiencing with the GDPR being enforced lately, how are you actually going to handle people being able to access their data from anywhere, but actually keeping to the regulations that they would expect?
I think it's something, so at least looking from within Microsoft's experience, and again, none of this is to pitch one vendor over another, the requirement is not just to be compliant, it's to bake in that capability at a base architectural level, right? Which is why I think it evinces that kind of effort and energy, is it's not literally just going through systems and having to create checkbox solutions of, in the event of X, we'll do Y. It's literally rebuilding the way data is processed, stored, and retrieved to allow for exactly this kind of multi-nodal but still GDPR compliant access to the same systems that you had on May 24 as you might have on May 26. That sort of regulation and those sorts of regulations in future might start to impose unsustainable architectural costs. I don't think we're there yet, but the possibility is certainly out there.
Okay, question for the audience? Ben over there has one, or? It's okay, I think that's Rob.
Yes, Ben Schichter from the United States Naval War College. So fantastic presentation, and I'll preface anything I have to say now with I'm no expert on cloud computing or cloud infrastructure, but based on the image you sort of threw up and some of the information that you've shared with us today, it seems that the infrastructure that underlies this sort of incredible system is dispersed across the globe, with information sort of being dispersed across that infrastructure. Increasingly, and I think this was discussed in one of the presentations earlier, the issue of physical security as a component of cybersecurity is becoming an increasingly large question. And what does that mean in terms of having a large, globally distributed infrastructure with access points around the world that could be a portal to information for a company that is geographically controlled or held in another part of the world?
It's a great question. I think it's something that doesn't often get discussed in the context of what cloud can do. There are strict physical security requirements that have been adopted as standard across the major cloud service providers. To gain access to these facilities is to go through a set of control points, physical barriers, and not just access infrastructure, but actual physical security, right? The kind of lockout and isolation that you would expect to see at a sensitive data storage facility for banking. It was impressive to me visiting one of these sites, the hoop that we had to jump through just to get in the front door. And I think that's a regular problem for them in terms of the cost and just having to deal with that friction, but it's a base operating requirement. So that idea of physical security and resilience is a really important one because these are deeply physical, tangible facilities, but I think it's one where there are some very clear international standards, so I'm happy to point you to that kind of stuff. Absolutely.
Great, thank you.
Thank you.
You're up. So our next presenter will be Pekka Nicolia. He obtained his doctoral degree in philosophy and physics in 2008 and serves as a researcher and officer for the Finnish Defense Research Agency. He has research interests in operational analysis, electronic warfare, and cyber. His paper is entitled Game Changer, Structural Transformation of Cyberspace.
Thank you very much. Well, first of all, this study and this presentation is related to Russia. Its aims in what we call in cyber domain, and the research does not represent the official view of Finnish defense forces where I serve, nor the Finnish state, but instead it's a result of three enthusiastic researchers and their work. So, second, please have a bitter and sweet news. No, I mean treats from Finland. So, well, it's related to, because in cyber context, if Western countries, if they go to that direction, Russia goes almost exactly the opposite direction. And it's what we have shown that the sort of the will, political will, is really on behind of that. And we've tried to analyze that what is the core reason for this. And that's basically the core of this result, this study as well. So actually I have to, of course, introduce my colleagues. Dr. Vissolainen, she's actually the initiator of this study, and she's very talented. She's fluent in Russian, as is also Captain Juha Kukkola. He's fluent in Russian. He is also a military strategist and an officer. And me, I'm more like a modeler and a physicist as well. But anyway, yeah, and to cut it short, well, essentially what Russia is aiming is that they are aiming to achieve the capability to close their national networks by 2020. They are aiming digital sovereignty, how they call that. They are aiming to, or they are performing structural transformation in their own cyberspace. And yeah, as a scientist and as a citizen as well, it's quite interesting to try to understand why. So this book, basically it's a series of 6 scientific articles, and they're all published actually last year. Well, actually, the latest one is in this year. So, so it's basically a cooperation of us 3 researchers, and here it's an outline of this book. We collected the result as a book as well, in order to, well, there were so many of these articles, and we just decided that okay, maybe the message is a little bit more clear in a book. And in my presentation, I mainly concentrate to the second article, which is the chapter 3 in this book. But now a short, how to say, marketing. These are the 3 very last hard copies of this. So if there are any presidents or generals in the audience, please. And also any other. So I leave them here. So basically, whoever has the courage to take them, you're free to do. So and also the book itself, it's open, it's free also in the internet. So you can see the let's see. I wonder which one is the. No, it's not this one. Yeah, so in here. So basically, yeah. Yeah, yeah. I knew that we are basically very in a shortage. So old edition was basically taken away as soon as they got it from the press. So well, basically, the thing is that Russia and also maybe some other countries, we are mainly concentrated in Russia, but they are really trying to structurally or restructure their cyber domain, and we, well, especially some of the articles, they are related to the fact that what is the military or the strategic aim in this big transformation, because it's a huge risk to the Russian state. So basically, first we noticed that in 2016 Russia declared that they really are. It was signed by Vladimir Putin, that they will create this closed national network, and then our research started. So quite soon we traced back that this has a roots already back to 2014, and actually even earlier. And in 2016 December they announced that this new information security doctrine, which basically stated the strategic sort of procedure how to do that, and also some other things, but that was one of the main ideas in there. So we actually wrote the first articles, and Ristolainen wrote her first article based on the announcement, and then the second and the third and so on based on the announcement and on the information doctrine, and some or a lot of Russian theorists on this issue, on this topic. So, and then of course whenever some new state level documents like strategies and law bills and so have been published, we've been analyzing those and try to publish as fast as possible, and of course try to be as objective as possible in order to find out the core message from there. So essentially one quite relevant question, that what would be the military aim or strategic aim of this? Well, as a soldier, as an officer, it's quite sort of self-evident to look on these topics on base of traditional combat elements. Well, quite rapidly, it is actually quite self-evident that it's you improve the capability at least in relative sense. So when compared to the adversaries, you are able to enhance your own capability versus your adversary. And well, of course, there's a discussion that okay, since they've announced that they're going to use own hardware, own software, there will be some new kind of technical vulnerabilities. Well, of course, as we don't know what are the solutions, we don't know what kind of vulnerabilities there are. We acknowledge that there most likely will be, and of course, yeah, I would say that it's worthwhile to study those if they are ever found out or so. But anyway, the result of this is actually we categorize this in let's say in 5 different scenarios, which are actually further divided by 2 larger scenarios or set of scenarios. And I would say that you can categorize in such a way that scenario number 1 and 2, they are related to enhancing your own military capabilities, and also if you have some friendly followers, well, we used, I'm a little bit embarrassed of this one, but a weak follower, it means it's not like a huge superpower or something like that. So, for example, China is not like this. So, and then if there are strong followers, then the situation is a little bit different, because then I would say that the critical mass is quite sort of, yeah, it's a question of who will adapt to which will adapt. So if you see that, I will just give a hint. The next slide, basically, this is how Russia has stated by themselves in the doctrines. They are aiming to find out allies. Of course, we do not know which countries are willing to follow and adapt like Russian type of thinking. But these are basically the main groups. So BRICS, CSTO, so it's Common Security Treaty Organization and Commonwealth independent states. So, but anyway, what I'm trying to say here is that in our model, well, basically West is in reactive mode, and I would say that well, it's a feature of this model, but it actually represents quite the real situation, because let's raise hands. Who would like to have a closed national network by definition? Okay, some, but they are in the minority. I would say that at first, at least. But anyway, the thing is that that I would say that the most, or we think that the most favorable scenario in Russian point of view is either this scenario number, was it number 4 or 5, nervous openness, which means basically it's that let's say Western alliances, Western countries, some sort of adapt these closed networks, closed national networks, some don't. There will be some, I don't know, some critical infrastructure. I don't know. Of course, we are not to say that who is the behind of these attacks, but because and the other thing is that it's really hard to attribute actually in technical sense. So, but I would say that in our articles we for example, we've analyzed that is one of the end results, and actually one of the other favorable end result would be that Western world would also adapt these substantially closed as a like a society. I mean, as a like alliance or so, because then it would be a clear information victory, and yeah, it's of course for a influencing country it would be a I would say good end result. So, but to conclude, actually I here conclude mainly the results of the second article. We have analyzed much further on. So so basically, I would say that these results can be concluded or sort of derived from the first 2 or 3 articles, and then there's actually much more in that book. But since hopefully I mentioned that I'm not a Russian specialist by myself, I'm in this position mainly because I'm a physicist, and I try to ask stupid questions whenever it's possible. So whenever if a colleague has some idea, I try to ask that, okay, what do you do here, and why do you do that, and so on. So that's the I would say quite honestly my role in there, and also building those models. But anyway, I'm happy to answer any questions if ever. So thanks.
All right, thank you. I'm going to stand because I've felt like Humpty Dumpty the entire time there, and I almost fell once or twice. Let me ask you though, on RUNet, RussiaNet, how does that increase firepower? Can you unpack that argument? Because it wasn't exactly clear.
Well, firepower, because you can basically divide firepower in 2 categories, in a way that firepower is the actual power, which say in traditional warfare it's like the power or the energy if your bomb or whatever. But the other effect is the how how distance you are able to operate with. So that's in the definition of firepower. So I would say that if this Russian system is successful, I would say that it most likely will have an effect to their adversaries' capability to operate from distance. And the other thing is that it will not have an effect to their own, like negative effect to their own firepower in that sense that if all the rest of the world is like open society, of course it's quite self-evident that you can have like topologically separated systems, maybe in the like other countries and so on. So basically you don't restrict essentially anything from your own capability. So.
Okay. Any other questions from the panel?
I was actually wondering, first of all, thank you for your talk. Do you think that by closing the border, not you, but anyone who does that, because there was one in the audience who also wanted to have that, do you actually think that you would really be able to establish digital sovereignty by that, because you will still have people inside?
Yeah.
And unless you actually want to go the way that you actually really go towards those people by putting them behind bars or whatever, or even military actions, I don't know, what you can think of, not just in digital terms, but actually physical doing harm to those people. Do you really think that you will be able to establish digital sovereignty by that?
It's a good question, and I would say that probably I'm not the correct person to answer to that, but we are really encouraging all the other scientists, for example, really in technical level scientists to look on this. But I would say that what we have shown is the comprehensivity or the, how to say, the large scale of this Russian closing network process and this digital sovereignty in a way that there are actually several so-called operational lines that, for example, one is related to the fact that you enforce more stricter like laws. So if let's say if you are like some citizen in your own country, and if you do something harmful in the internet, you get into jail, like I don't know, but like for a very long time. So and there are also other measures. They are mentioned in the book, and we have studied further on. So, yeah.
Okay, thank you. There's a question in the back over there.
Thank you. Keir Giles, I'm a colleague of Kim's. When the Russian authority is explaining to their own population the measures that you've described, the preparations you've described, there are a couple of different mixed messages that come across. There's the self-protection narrative, and there's also the narrative how the evil West, led by the United States, is preparing to cut Russia off from the internet, so we need to be ready for this. So there are two questions that come out from that. And the first is, did you or your authors, co-authors, get an assessment from the materials you studied as to whether this suggestion from Russia that the West might be actively seeking to cut Russia off is a sincerely held belief or just part of the Western threat narrative? And the second one is, under what circumstances do you think Russia might accelerate the process and decide to pull the plug suddenly and possibly without complete preparations?
Yeah, they are very good questions. Thank you. Please, next questions. So the answer to the first question is really so that basically it's part of the big sort of story in how Russia justifies this for their own people. So basically it's protection, and especially protection from the Western world. So, but I would say I think that's everything that I'm able to say about that. So in that sense, I would say that. But yeah, The other question, you mentioned that if there is, if in some sense Russia would be sort of motivated to try to enhance the process. That's also a question where I have to say that I do not know, and even if I knew, I was not able to give my estimation, but the situation in a strategic level may change into that direction, that it's favorable or less favorable some states to act actively. But of course we are not to say that if that's going to happen or no.
It's also something we need a lot more research on oppositional decision making, because we kind of project onto the opposition, but we don't really internalize what their goals and motivations are, and we need more research on that sort of perspective. Any more questions? A quick one? We got a little bit of time. Well, we're running up on the time limit anyway, so I thank the panel for their wonderful presentations, and I hope to see you for the rest of the conference.
Yeah, thank you.